For this project, we traveled to the northwest region of Tenerife, a small volcanic island that lies around 200 miles west of Morocco, to carry out a wildfire assessment. The average yearly temperature on the island is 24.8 Celsius degrees and average rainfall just 208 millimeters, according to Met Office. Tenerife is under constant threat from wildfires, with events occurring in 2002, 2007 and 2012, since the turn of the century. The reason for these short intervals between events is to allow for sufficient build-up of materials and biomass. The 2012 event burned around 12,000 hectares of wood and shrub land, with the 2007 event burning a further 17,000 hectares. It is also estimated that a further 24,300 hectares were burned between 1983 and 1998. Wildfires typically occur during the summer months, during the dry season because of high temperatures or lightning strikes, or during periods of volcanic activity. This is of interest as the island receives around 4.2 million tourists annually, mostly during the summer months. This means there is an escalated risk to the public because of the onset of wildfires, with the island's population effectively doubling during this time. One of the main contributing factors to high wildfire prevalence in Tenerife is the dense population of the dominant native tree species, Pinus canarius, a paraphytic species with layers of resistant bark and pine cones that are only open to disperse seeds after being subjected to high temperatures. It also has long, thin, waxy needles, which makes it particularly effective at spreading fires. The wax on the needles causes them to be flammable, meaning just one small ignition point can cause the entire canopy to be engulfed. Another contributing factor is the dense buildup of leaf litter from falling needles, especially in unmanaged areas. This buildup of litter acts as a large, wide-spanning fuel source, allowing the rapid spread of flames at the ground level and, in turn, the ignition of trees from the base upwards. However, wildfires can pose significant threats to populated areas. They have also been shown to be beneficial to soil nutrient composition and ecological regeneration. Wildfires occur more frequently around the Corona Forestal Nature Reserve due to the dense coverage and reproduction of trees, particularly in areas around the north and northwestern areas where the climate is more humid. However, wildfires can also occur in northern parts of the nature reserve, such as Villaflor, where the climate is semi-arid. The current management system in place in Tenerife have been questioned, as there is a lack of standardized fire safety training across parts of the island, and no training centers specialized in wildfires like those overseas. Similar species of pine also experience frequent forest fire events globally, such as the Jack Pine Forest of Michigan, USA, most recently in 2012 and 2007, but less frequently than Tenerife, with only 4 events occurring between 1900s and 2000s. However, in contrast to Tenerife, Michigan exercises good practice when it comes to wildfire management system. It provides daily fire danger ratings, wildfire safety tips, burning permits, restrictions and prescribed fire. This type of fire is intentionally lit to accomplish a specific objective, such as ecosystem rejuvenation. Australia is a global hotspot for wildfire, with some areas burning on a yearly basis. Severe events occur in a close relationship with heat, drought and El Niño southern oscillation. On 7th of February 2009, over 400,000 hectares were burned in Victoria, killing 170 people and destroying 2,000 homes. This was the most devastating wildfire event in the known history of Australia. It followed 2 months of hot, dry weather and a recorded temperature of 45.1 Celsius degrees on January 30th, just 1 week before. The fire was started by sparks from power lines that fell in the 100 km/h winds, igniting the dried vegetation. This is a prime example of the effects wildfire can have in a populated area.
The aim of our project is to investigate the susceptibility of the Mindera de Chillo campsite and the Chinero Cindercone to wildfires. Our objectives for our project are to identify differences in physical characteristics between managed and unmanaged areas of the Canarian pine forest, to discuss the likelihood of fire ignition at each site and to compare differences across both sites to identify levels of hazard susceptibility.
Okay, so the two sites we have selected for this assessment are Mendera de Chio campsite and the Chinero lava flow cinder cone. The first of these is a mitigated area, and the second is a rather relatively unmitigated area with previous history of wildfire. So in both of these areas we will be looking at a flat and sloped area in a 50 metre square grid to get a representative sample of both areas.
Okay, so here we are at the sloped site that we have chosen to take some data recording. We've chosen to do a sloped site because it will allow us to compare the effect of topography on the spread of wildfire compared to the flat area that we're going to be taking some more data at later on. The methods that we chose to use to collect data here are using a ruler to measure the leaf litter. This can tell us how quickly the fire may spread, and we can use it to identify areas where the fire might spread more quickly or less quickly, or where a fire break could be. We then used an ABNY level to measure the height of the trees and the height of the burn if present on the tree. We then used a measuring tape to measure the furthest extent of the branch that reached the furthest away from the tree on it at each point, and we used a measuring tape to measure the distance to the next closest tree of the same kind. We also used a mobile phone to measure the angle of the topography of the ground at each point to see whether the slope differs by a lot or not.
This is the flat, unmitigated area of wildfire that we measured out. We did 50 square metres with 10 points measured at 10 metre apart gap. We chose this area because it's a good comparison to our slope site we did earlier in the day, and with the campsite we're going to survey tomorrow. So we have scrub bushes and trees and lots of leaf litter to do. But we chose this bit because it's the flattest area opposed to the cinder cones, and there's two tongues of lava fields. So we're sort of in the middle bit.
We chose this site because it is a mitigated flat site compared to the unmitigated flat site we visited yesterday. This area has picnic benches and ovens, so human influences of fire are more prevalent here.
This is in our flat mitigated area to compare to the flat site from the unmitigated area yesterday. This is one of the barbecue pits. So they're both well used, however they were quite well mitigated against, so don't know, the leaves get raked up reasonably regularly and they get put into a large pile and then they're burnt in one of the pits. So a lot of the ground has been swept up, and the bits you can see are just those that have fallen since the last clearing attempt. So yeah, this is the other side, and you can see a bit better now that up to the edge here it's mostly swept, and a bit beyond it's not. So yeah. So we're in luck, and while we're here, park rangers are burning pine needles up. Cool, eh? So he's carrying it to the burn point and make it all nice ground that won't burn too much, probably.
Okay, so the benefit of taking GPS readings through the entire fieldwork means we can actually utilise that to distribute our data spatially using Google Earth. So if we move into our first site, we will actually be able to represent our data as bar charts, or bars, on the areas. So across these sites we've used a series of bar charts. The green ones are currently representing tree height, with burn height being represented as grey along the bottom. So we can see the trees and burn heights all distributed across the waypoints. From this we can already see a significantly average burn across the entire site. The blue area is currently representing canopy coverage, which we can see is actually quite dense around the base of the cinder cone. Now if we look at litter depth across the site, we can see an average layer of litter depth across the entire thing at around 6 to 8 centimetres for our sloped site. Now if we move to our flat site, we can already see a slight difference. The trees and the tree heights and burn height are about average for the same, so it shows significant burn height across the site. The canopy cover is significantly less dense in several areas. We do have more zero readings across the site. What's important to note is the litter depth across the area, where we do have one or two spikes. What's important to note is a range of spikes across the first line, which actually coincides with a path running through. It's likely this is just to do where the path has been cleared and the litter has been brushed to the sides. Now, by comparison, our second site, Mendera de Chio, is significantly less dense. Immediately you can see this in the way it's been distributed. So for our flat site, there are more trees across the site in general, but compared to the first site, significantly less. There is virtually no burn. Obviously the burnt trees have been removed, that this is a mitigated site, with the exception of one incident where the burn was around 1 metre at best. The remainder of the site we saw no burn whatsoever. The canopy is significantly reduced by comparison to the cinder cone sites, and the litter depth was virtually non-existent. At most sites it was unreadable, so these resulted in 0 readings. Now at our sloped site, which is further up in the campsite, again even less trees, or only 1 or 2. There were trees at the site, but some of these were not picked up by our sampling strategy. Only one minor incident of burn at less than 1 metre. Canopy coverage again very small, hardly anything. And the litter depth readings, there were only 1 or 2 areas where it exceeded 1 centimetre. So overall the site significantly less compared to our unmitigated sites.
Comparison of tree and burn heights across the mitigated and the unmitigated slopes show a significant reduction in burn heights in the campsite area. This is likely due to the level of mitigation in the place where the park wardens have removed burnt trees and from previous fire incidents. In the unmanaged sites, the burn heights average around 4 to 6 metres in height. This would suggest that the fire spread through the trees and surface but did not reach up in the canopy. The burn heights could be due to the topography of the ground. Wildfires are able to burn much quicker going up a slope, as access to unburnt trees in front of the wildfire becomes easier as the radiant heat preheats the trees, making them more flammable.
The graphs indicate the litter depth around the unmitigated sites. The blue lines is considerably higher, with depth readings ranging from 2 to 10 centimetres. By comparisons, the readings from the mitigated sites, the red lines, do not reach higher than 2 centimetres, with the majority of sites having no measurable litter. This is a representation of the litter management in place at the mitigated sites. It is also likely that the density of trees within the unmitigated site has contributed to the thicker build-up of litter.
So, this graph is showing the distances to the nearest tree from each of our sampling locations. They are showing that the campsite, the mitigated site highlighted in red, has significantly larger distances than those highlighted in blue. The average is around 8 to 10 metres at the red sites, with the blue site, the mitigated areas, showing distances of only 4 to 5 metres. This is providing clear evidence of the mitigation in place at the campsite, as there is no reason for this distancing other than anthropogenic deforestation. Now, we believe most of this had occurred between the 2002 and 2007 wildfire events, with further activity occurring after the 2007 burn.
So here we have the canopy sizes from the mitigated and unmitigated flat site, as well as the mitigated and unmitigated steep site. So if you look at our red lines on both graphs, you'll see the mitigated sites. The tree canopy covers are a lot sparser on both your flat and your steep site, with readings no more than about 2.5 metres. Whereas if you're in the unmitigated site, you'll notice that the canopy sizes seen here and here in the blue are a lot bigger, with average readings about 4 to 5 metres. This slight increase in average canopy size does suggest a greater risk of wildfire in the area. The slight increase in canopy size does suggest a greater risk of wildfire spreading around the cinder cone area, which is our unmitigated site. So there are several improvements which we could do over the sites. These are split into two main categories. The first category is human error, and the second category is methodology issues. Human error created a problem, as when it came to concluding our fieldwork, our 50-metre square grid sampling method wasn't exact. This was due to topography and land cover. We also had to take into consideration personal safety. The data was also collected by several people, which took time to collate in one place. Each person also collected the data in their own way, which gave skewed results. The methodology issues contained instrument errors. The GPS recorded additional waypoints unrelated to the sampling, which made the data harder to interpret. The data sampling method was strategic systematic sampling. This was chosen due to the ease of access to the site, which did exclude areas due to inaccessibility. This sampling method also excluded data. Trees that were not identified in the grid pattern were excluded. A different sampling method, such as a tree survey, could have been more representative of the site. Okay, so one of the main things we need to note is that we're basing quite a lot of the trees that are missing on speculation. So what we're assuming is that the trees that were damaged in the 2007 fire have either been removed because of the burn, or they were damaged in the 2002 fire and have since regenerated their bark. We are unable to prove this, as we were unable to talk to any park rangers due to a language barrier and also the fact they were quite scary. So trees have also been cleared to create paths and an area in the slope site for a rounds pitch. This was noted down in our data collection. Another thing we noticed at the site is that certain trees had the top removed of them. We were assuming this was to reduce the total tree height as well as the canopy cover.
In conclusion, at the campsite, there is a higher probability of a wildfire ignition. This is due to a higher anthropogenic activity in the area, which can be seen through the increased amount of anthropogenic litter left on site, such as cigarette ends and broken glass, as well as the fire pits and the park benches. So more litter, more chances of it happening. So this increases the likelihood of a wildfire starting. However, due to mitigation taking place at the campsite, with the increased distance between the trees and less canopy overlapping and the removal of the litter, by removing the fuel, this decreases the probability of a fire, even if it started, from spreading without the ability to combat the fire quickly and effectively, preventing it from spreading to the surrounding area. In comparison, the Tenerife cinder cone site, which is unmitigated, has a greater average leaf litter depth coverage over both the slope and flat survey areas, as well as denser tree growth surrounded by other regrowth such as saplings and scrub bushes. The canopy cover, which is also much more overlapping than at the mitigated site, and these factors will encourage a started wildfire to spread. A wildfire in the unmitigated area would also be more difficult to fight due to a lack of access compared to the mitigated area. However, there is a reduced amount of anthropogenic activity at the unmitigated site, so it's less likely a fire would start there through anthropogenic circumstances and more likely through natural means, which is much rarer. Thank you very much.